Starting in Chapter 9, we're going to be talking about prisms, pyramids, cylinders and cones, and then we'll end with spheres and talking about how to find the surface area and the volume of these figures. All right, so first let's talk about prisms, which in the most general terms you can think of as a box. Every prism will have two parallel planes, and on that plane there'll be a polygon. So the planes are parallel, and here we have triangles in both planes. Here our planes are parallel, and here we have quadrilaterals. Actually, they're called squares in both planes. They may cause right angles, or they may be a little askew. But we're talking about basically your three-dimensional figures. So congruent figures, congruent polygons that are going to lie in parallel planes are the bases of the prism. So you might have a triangle for a base, or a square for a base, or a pentagon for a base, or an octagon for a base. You're going to have a you're going to have a polygon as a base. And the parallel lines don't need to be shown in the drawings, but typically we're going to show them because the height is sometimes an important characteristic of the prism. The prism does not contain any interior points. We think of it like an empty shoebox. All right, so we're not really including the points on the interior. Now there are times when they'll say that you've got a brick, so that would be filled in, or a wooden block in the shape of a cone, that would be filled in. So if the problem says all the points on the interior are included, well, then you include them. But typically they're not included. So let's look at these prisms. Here we have the segments AB, AC. See these segments, the sides to the polygons? Those are the sides to the bases. So they're going to be called the base edges. Here I have the sides to the square, so those are going to be called the base edges. Now, the line segments connecting the parallel planes, those are going to be called the lateral edges. Lateral meaning side. So here we have a lateral edge here and a lateral edge here. So we've got bases, base edges, lateral edges, and each of the sides of a prism is considered a lateral face. All lateral faces are rectangles. So for a prism, there's always going to be a rectangle on every side of your rectangle. So the bases and the lateral faces are considered the faces, but we would normally call them, you're going to have two bases, and if there's a pentagon, you're going to have 5 lateral faces if the base is a pentagon. If the base is a triangle, you're going to have 2 bases and 3 lateral faces. Every corner is called a vertex. Every corner of your prism is called a vertex. And this is all going to go into the naming of our prism. So here's a vertex, and here's a vertex, and here's a vertex on one base, and here's a vertex, and here's a vertex, and here's a vertex. Now, if the lateral faces meet the base at a 90-degree angle, it comes to a corner, like you would imagine the corner of a room, that would be called a right. It's a right angle, so that would be called a right prism. If they're kind of slanted off to the side, you can see how this prism is slanted and off to the side. This would be called skew because the angle that the lateral face meets the base is not a 90-degree angle. Okay, so talking about prisms. Prisms here, you can have a right prism if that's a 90-degree angle, or an oblique or skew prism if it's not a 90-degree point of intersection. And so now how are we going to name our prisms? The names of the prisms are going to be, first of all, by the kind of angle. So it's either going to be right or oblique. Some books call it skew. And then it's going to have the name of the base. So whether it's a triangular or square or rectangular or pentagonal or octagonal, and then the word prism. The word prism is going to tell us two bases. So the shape tells you the shape of the bases. It's also going to tell you the number of lateral faces that you're going to have. Now the distance between the two parallel planes is the altitude or the height. So on our right prisms, which is mostly what we're using, the altitude is the length of the lateral edge. So here's our first practice here. Let's name each type of prism here. All right, so these are meeting at right angles, so this is going to be a right. What's the shape of the base? 1, 2, 3, 4, 5, 6 sides. Hexagonal, and it has two bases, so that's a right hexagonal prism. Let's look at this one. Well, first of all, we can see that the angles do not meet at 90 degrees, so we're going to call this one oblique or skew. How many sides in the polygon in the base? 1, 2, 3, 4, 5. It's a 5-sided polygon in the base, so that is going to be pentagonal. It's a pentagon, so described by pentagon as pentagonal. And prism, we're going to use the word prism because that describes that there are two bases. Because when we get into cones, that'll have a different type of base, and when we get into pyramids, that will only have one base. So all three words are important. All right, we meet at right angles, so we're going to call this a right. And notice here they're telling us the bases are equilateral triangles. So all three of these sides and all three of those sides are all congruent. So we would call that a right. You could call it a right triangular prism, but let's be as specific as we can. A right equilateral triangular, and we're going to put the word prism so that we know that there are two bases. Right equilateral triangular prism.